Some say the moon. Why choose this as our goal? And they may well ask, why climb the highest mountain? Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.
So make sure you see where the exits are. So I really appreciate the ASC having their event here today. For those at JSC, you know, the ASC is made up of people that have flown in space. You have to do one orbit, is my understanding, at least as a minimum. But they are incredible leaders and courageous people who have led the world in exploring space, and they have an association that gets together, and they picked Houston as their location this time. So it's great that they're here today, and they're sponsoring this panel with this distinguished group. And I appreciate that they came here so our employees can hear it, and of course we're online as well. So what I would like to do is, this panel is really about Apollo, and what I'll do is I'll introduce each member, although obviously since you stood and applaud, you know who these guys are. But we'll do a short introduction first. I'll run through all of them, then each of them is going to give an overview about their experiences in Apollo, and then we'll do questions and answers. And the questions and answers, a lot of you have put questions online, and some of you have voted those, and so we'll start with a couple of those, but we'll also have a mic here in the auditorium. You see it on the end there. So as you're going through and you hear those first questions that we did online, feel free to get ready and come up and ask a question, because we will take questions from the audience. So what I'd like to do first is start with introducing our panel members. The first is, of course, Mr. George Abbey. Mr. Abbey was a technical assistant to George Low, among many other things, during Apollo. He was director of flight crew operations and eventually the center director here at the Johnson Space Center. Next is Walt Cunningham. Walt, of course, among many things, flew on Apollo 7, and you might remember Apollo 7 was the first launch of the Apollo launch and capsule system. Next to him is Fred Haise. Fred Haise was a lunar module pilot on Apollo 13, among many other things. And of course, Gerry Griffin on the far end was Apollo flight director for many of the flights during Apollo, and also was JSC center director. So that's our panel. So what I'd like to do now is start with Mr. Abbey and have him give an overview of his experiences in Apollo. Mr. Abbey.
Thank you, Mark. Well, I think looking back, the space program as we have come to know it really got started when our friends in the Soviet Union launched Sputnik back in October 4th of 1957. And that caused, I think, a lot of consternation in the Western world that the Soviet Union had that kind of technology, caused a lot of concern. And the next year it led to the formation of NASA in October of 1958. And shortly after NASA was formed, the Mercury program got started in December of 1958. And of course, the Soviet Union had continued to do rather spectacular launches and had launched animals and had also started a manned program. But in 1961, a new president came in, and he came in with an administration that had a lot of promise and was going to make great changes. And in January '61, he was sworn in as president. And about 2 months later, another event occurred that really caused a lot of consternation again, when Yuri Gagarin was the first human to fly in space, orbit the Earth, on April 12th of 1961. And then about a week later, there was a abortive invasion of Cuba that embarrassed the administration. So the new administration under Kennedy was really concerned about trying to do something that would change the outlook of the way the things were going. And at that time, they had formed a Space Council that was headed by Vice President Johnson. And so President Kennedy asked Vice President Johnson to look at coming up with a proposal that would give us an opportunity to do something that would at least give us a 50-50 chance of doing it before the Soviet Union. And about 3 weeks after Yuri Gagarin flew, Alan Shepard did a suborbital flight. And 3 weeks after that flight, the Vice President had come back to Kennedy and recommended that we take astronauts to the moon and safely return them to Earth. And on May 25th of 1961, President Kennedy spoke to a joint session of the Congress and said we're going to go to the moon and do it by the end of the decade. And at that time, we'd only flown one Mercury flight, that suborbital flight. John Glenn didn't fly till the next February, and that was our first American that had orbited the Earth. And so we got underway trying to figure out how we were going to get to the moon. And there was a lot of differences on the approach, whether we do a direct descent or we would put together stages in orbit. But an individual at the Langley Research Center, an engineer there named John Hubolt, came up with an approach called lunar orbit rendezvous. And that approach was not given a lot of attention. And so he wrote a letter directly to the Deputy Administrator of NASA and said that this was the approach that ought to be used. And he gave that to Brainerd Holmes, who was head of spaceflight in NASA at that time. And not a lot of action occurred, except George Low did get a chance to look at it, and he thought it was a good approach, but not much action was taken. And finally, George Miller replaced Brainerd Holmes as head of spaceflight, and he brought a new deputy in called Joe Shea. And the Deputy Administrator of NASA, Robert Siemens, asked Shea to take a look at this approach. And Shea looked at it and looked at it sounded like a reasonable approach and a good approach. But he had to convince the director of the Marshall Space Flight Center, Werner von Braun, and also really convince Bob Gilruth, who was Center Director of the Manned Spacecraft Center, which is now the Johnson Space Center, and convince them. And it took about a year of going back and forth. And finally, in the summer of 1962, we decided on the lunar orbit rendezvous approach. And lunar orbit rendezvous, of course, is what we ended up using, but in order to do that, we had to really get experience on doing rendezvous and doing dockings and build up experience that we weren't getting from Mercury. We continued to fly the Mercury flights, and the last flight was flown in '63. And we started a new program, Gemini, which was a two-man vehicle that was going to give us the opportunity to do rendezvous and docking in space, and also develop the new systems that we needed in order to do Apollo, the fuel cells, for example. And the Gemini program was started, and we ended up flying 10 Gemini flights. And then after the last Gemini flight, first flight was flown in '65, and then the last flight was flown in November 1966. And so Apollo was going on all during that time, and Gemini turned out to be the essential step for Apollo. So it gives us all that experience and learning those techniques, learning how to do the rendezvous, and give us the systems we needed for Apollo. So the first flight of Apollo was planned in February of 1967, right after Gemini had been flown. And that first flight we had on the launch pad, and normally before a launch we do a countdown demonstration test. And we were doing that test in January, about a month before the flight. And we had the crew on board, and we have everything just like it is on launch day. The hatch closed, and in Apollo we were flying with 100% oxygen. And at that point we were really not paying as much attention to traffic in and out of the crew module as we should, and wiring had gotten frayed. And so during the countdown demonstration test, wiring, there was a spark. We had a lot of nylon inside the vehicle, and in 100% oxygen, that burns very well. So we had also an inward opening hatch, which was not good. So the crew was tried to get out of the vehicle, but they weren't able to, so they ended up suffocating because of the smoke. But we lost that crew, and that set the program back. Certainly, it didn't look like we were going to land on the moon by the end of the decade, but we had to find out what caused the accident, and then we had to fix the problem, and we had to develop all kinds of new materials that didn't burn in oxygen, which we did, and tested those, and then we had to fabricate everything went into the crew module out of that new material. And we were successful in doing that, and we also had to design and build a quick opening hatch, outward opening hatch, which we did. And we also went back and looked at other systems and got more redundancy in the vehicle. And that took about 21 months, and we were finally ready to fly the first manned flight again in October of 1968. And the crew that was on that flight, of course, was Wally Schirra, Don Isley, and Walt Cunningham. They had been the backup crew for Apollo 1. And so we were getting ready to fly that flight, and the individual I worked for, George Lowe, who was the Apollo spacecraft program manager, had taken a short vacation in August. He'd been working 7 days a week, almost 24 hours a day, ever since he took over as the manager of the program. So he took a brief vacation, and he came back and told me that I don't think we're going to make it by the end of the decade if we stay on the present plan. So we need to change. And he said, I'm going to propose that if we're successful on Apollo 7, we will take the next flight to the moon of the command module, Apollo 8, 2 months later. And he talked to Chris Kraft to see if that was a feasible plan, and Chris Kraft came back in about 2 days and said, yes, it was. And so they convinced NASA leadership, and so the plan was if Apollo 7 was successful, 2 months later we would go do Apollo 8. But we had another problem that from that spring of that year, or in April of 1968, we launched the second flight of Saturn V. And the Saturn V first flight was very successful, but the second flight was not so. We had major oscillations on the first stage, and we lost 2 engines on the second stage, and the third stage engine that we needed to use to insert on a lunar trajectory wouldn't restart as it's supposed to. And the spacecraft LEM adapter that surrounded the lunar module came apart. So at the same time we were getting ready to fly Apollo 7 and hopefully fly Apollo 8, we had to fix those problems, and the first flight, manned flight of a Saturn V was Apollo 8 in December of 1968. And that was shortly after that flight in April, which was not a good flight, but we were at the point where we were convinced that we had to fix those problems and were ready to fly the Saturn V again with men. And so on December 21st, we launched Apollo 8, and they went into a lunar orbiter on Christmas Eve in 1968. And that was the first time we really saw the moon close up, because they had taken a television camera. So as they orbited the moon for that first time, they showed the moon, and then they read from the Bible. And it was a very emotional Christmas Eve for everyone in the world that was watching it. And probably, maybe as you look back on it, at least I look back on it, Apollo 8 was probably more emotional for me than Apollo 11. It was the first flight that we sent humans out of Earth orbit. But that flight was very successful, and then 2 months later we launched another flight in Earth orbit to test the lunar module, because we'd only taken the command module and service module to the flight on the moon and on Apollo 7. So on Apollo 9, 2 months later, we took a lunar module for the first time on a Saturn V in Earth orbit. The crew separated in the lunar module, Jim McDivitt and Rusty Schweikert, and then re-rendezvoused with the command module with Dave Scott. And that proved the lunar module, and we were convinced we could take it to the moon. And 2 months later, in May of 1969, we took Apollo 10 to the moon. And that turned out to be a very successful flight with the lunar module. module in lunar orbit. We did not land. We descended to a low altitude over the landing site we were going to use for Apollo 11, but didn't land and took photographs. And we tested the ascent stage and the separation and came back and re-rendezvoused in lunar orbit with John Young, who was flying the command module. Gene Cernan and Tom Stafford were in the lunar module. And that flight turned out to be successful. And so 2 months later, we went to the moon on Apollo 11, and the rest is really history. And we had achieved our goal of landing on the moon before the end of the decade. So we thought we could really go to a more relaxed schedule, so we didn't go back to the moon until 4 months later on Apollo 12. And on Apollo 12, we had been concerned about the mass concentrations on the moon and wanted to try to do a pinpoint landing. So on Apollo 12, we were going to launch and land next to a unmanned surveyor spacecraft that had landed on the moon. And we successfully achieved that. But we did have some excitement during the launch phase when we launched right after a cold front had gone through and lightning took out everything on the spacecraft during the launch. And we were able to recover that based on a young engineer in the Mission Control Center, John Aaron, who was able to figure out what had happened and tell the crew what switches to throw to get the power back. But after orbiting the Earth and convincing ourselves that we had a good spacecraft, we went ahead with the mission and sent Apollo 12 to the moon. And then, of course, Apollo 13, and Fred is going to tell you all about that. And then Apollo 14 a little later, and 15, 16, and 17. So Apollo turned out to be a great program, and at the time we stopped, we still had some additional Saturn V's and additional command modules. And for those of you in the ASE, you're going to see one of those Saturn V's that could have flown later this afternoon. So Apollo turned out to be a great program, and you're going to hear more about that from my colleagues here.
Thank you, George. Great. Thank you, George, for that overview. So now I'll pass it on to Walt Cunningham.
Thank you very much. And your memory is so much better than mine. I will correct you on one of those small things you were saying. But when we look back, it's actually 51 years ago today we flew the Apollo 7. And I feel extremely fortunate in my whole life in being on that crew. Today, very few people, I think even in this audience, have an understanding of kind of how the logistics and what went on back there. Because that was the third crew that we were on, third attempted to get to go to that first mission. And I see that our society today, within the space program, it seems to be evolving. It also seems to be, to me, that people are much more oriented towards safety and things like that than we used to be. I'm one of those people. I guess maybe I'm ancient. I think you've got to be willing to stick your necks out to move things forward. And we did, a hell of a job on that back in those days. And our crew, Wally Schraw, Don Isley, and I, we were first assigned, and we were the second mission. Gus, Ed, and Roger, they were on the first mission. We were the second one. We were assigned at the same times. That was the beginning of '66, like January. I think publicly they announced it 4 or 5 months later. But we were living with the contractors. The contractors were not as far along as you might look today or look for them to be. So we were helping them develop the hardware, the testing, and all of that. And I'm sure some of those things that we did were not all pluses. Some of them were slowing them down, or they were just things that made us feel better about switches or something like that. But we lived and breathed with them. And North American Rockwell, out in California, they had great confidence in their spacecraft and how soon they were going to be able to fly it and all of that. So when we began working with them, and not just our crew, but I mean, it was the first two crews, they started slowing those things down. They had a lot of things to fix that they weren't planning on fixing at one time. And after 7 or 8 months, Wally, Don, and I, they had delayed things more and more, and they canceled our flight. So now we had no flight, and about a week or 10 days later, they then went ahead and changed the next flight as well, and we became the backup crew for that Apollo 1. It wasn't called Apollo 1 in those days, incidentally, but it is. Everybody buys it as Apollo 1 now. And then when we were on the backup crew, we were living very closely from, I think it was like around, I don't know how soon it was, like October. I think it was like October when we put on the backup crew. We started living with Gus, Ed, and Roger. And when it got down to January 27th, they were performing a particular test. That was the test that we had done the night before. But that was, when we did it, we had not had to close the hatch. And that was the last hatch that operated the way it was before they got killed. So we did not have the hatch locked. And the next day we were still training, but we were trying to wait for them so we could all fly back together here. We loved flying in those days. We got lots and lots of flight time. We loved it. Well, it got down to about 4 o'clock on a Friday, and we decided, well, we better fly back because they still hadn't done it. They'd had that cockpit. It had been closed up. It meant they had 100% oxygen, soaking everything up for, I guess, a couple of hours in there. We flew back, the three of us. When we got here, there was the flight officer was out there meeting us as we were parking our airplanes, which was very unusual. Went inside and found out that the crew was gone. That meant no flying for that time. That was January. Was that January or February 27th? Yeah, January 27th. When that happened. Well, a couple of weeks later, then we inherited the first crew. And 21 months later, and after they'd made, I think, 1,040 changes in there, we finally get down to time for the countdown. And I have to say this, that flight was so, the equipment were all so perfectly done in it that while we had a few problems here or there or operational problems like that, we ended up flying that for 11 days. And even though it was scheduled for that 11 days, I can't say that anybody was terribly confident we were going to make 11 days. And things were going so well on that mission that they added 4 more important mission objectives onto it. So when we got down, came back, there may be some internal problems, which some of you might read about or talk about, but when we got back in, it was declared 101% successful. And that was a good start for the Apollo program because we were counting on every one of those missions. And they had been looking at Apollo 8 for a number of weeks about going out around the moon. But there was no commitment to it. In fact, that commitment, there was a kind of a fight going on before it lifted off. Well, I shouldn't call it a fight maybe, but there was a lot of disagreement. It took them about 6 weeks, I think, or 5 weeks to say for sure that that's what they were going to do. And they did, and they had a brilliant mission on that. Even today, as you look back on it, you'll find that Apollo 7 was it was the longest, most ambitious, most successful first test flight of any new flying machine ever. And as time went on, I began to feel very, very fortunate that we're doing what we're doing and enjoying it and being successful on the startup. Thank you.
Thank you, Walt. Fred.
Now, Apollo 13 has had a lot of exposure in several books, even a Hollywood movie, so I'll try to do a little reading between the lines that maybe some of you have not heard about or seen. Approaching this mission, I had been a backup on 2 previous missions. I backed up Bill Anders on Apollo 8 and Buzz Aldrin on Apollo 11. And so we were coming up. This was going to be the 7th flight of the program, and the hardware and things looked like they'd settled down, and we had a good ship ready to go, and hoping to have a good mission. I should have known that something wasn't quite normal in the week before launch, when we were all exposed to measles through Charlie Duke going to a birthday party with his son. So we spent the early part of that week, every morning they took blood samples and sent them off to some measles expert in Cincinnati, Ohio, to check our blood. And they finally came to a conclusion that Ken Mattingly was highly susceptible to come down with measles. Our crew was Jim Lovell, commander, myself, and Ken Mattingly, and we had been the backup on 11 and now had trained to fly 13. Ken had never been married, had never had measles as a child. And incidentally, today I think he's 2 years younger than me, so he's 84 and has never had measles to the date. But at any rate, they made a decision 2.5 days before launch to change out a crew member. Now, you might think that's a hazard in a sense of mission success or safety or whatever, but as a backup, I can tell you, I trained to the point I felt confident I could replace the prime crew on either of the 2 backups that flew, because that's the way we trained. So actually, you could change out a whole crew in the week before launch. But at any rate, it was an emotional thing because as a backup, I'd found as you got close to launch with them, say a month away, you figured by then that the prime fellow wasn't going to break his leg, and so you weren't going to get to go. And so you'd done all this work and getting ready, and you knew you weren't going to go, so you kind of backed away mentally from thinking you're going to fly the mission. Whereas the reverse was true, I think, for when you really know you're going to go, you really start getting excited about it. And looking at that booster out on the pad all lit up at night, thinking you're about ready to finally get your chance. And so that was a very emotional swap between those 2 individuals 2.5 days before launch. And unfair in a way, because Ken had guests coming to the launch that now weren't going to see him launch. He had prepared a personal preference kit. We were allowed to take things to fly, and his was all packed on board. Conversely, Jack didn't have the time to get all his girlfriends there. He was a bachelor. And make the rounds like I did with family and friends to think of things I might take with them on the flight. So it was more of that kind of a thing, not a fact that we were worried about Jack filling in and doing the job. Now, it did require us, we were in simulators till about 8 o'clock the night before launch, mainly going through the dynamic phases of launch, entry, rendezvous, et cetera, where we had to work together. And even though as crews we'd use the same checklist, same flight plan, we wanted to make sure there was not some comment or discussion between the crew that was different than what we had done and within our crew context. So anyway, that was it. We got ready to go and had a good lift off. And again, second stage, we got up to a point and one engine quit a little over 2 minutes early, center engine on the second stage. Now, it was interesting, later I talked to Dick Smith when he was center director at Kennedy, and he had been the Saturn manager. Dick told me we'd encountered POGO, again, that dynamic fluid instability oscillation, and he said there was enough structural deformation they had seen in cruciform structure on the second stage had it gone much further before the engine shut down. The Apollo 13 movie might have been a very short movie. But at any rate, the 4 engines continued to run a little longer than planned, and a little more taken out of the third stage, but we still had fuel to continue the mission and leave Earth and head to the moon. Once again, we had a period of almost 2 days where things were very normal. In fact, we staged a TV show that by then this going to the moon was kind of a blasé to the major media, and they didn't even carry it. But it was just after this TV show that Jack Schweigert uttered that statement to Mission Control that Houston, we've had a problem. We'd suffered this, what was called an explosion that actually was a electric short within an oxygen tank and a severe overpressurization in that whole cavity, and blew off a quarter of the spacecraft. That panel let go. So unfortunately, it was not a typical explosion of shrapnel flying around, or we would have been in big problem there, because the very thin wall behind where those tanks was the main propellant tanks for the command and service module, which were relatively smooth. The first thing on the agenda that Mission Control got to work figuring out, quote, now this alternate plan, was to get us back in a good direction to get home, because at the time we were not on a free return, which would normally allow you to loop around the moon and be roughly on the path to get back to an entry. And so the first thing they were scratching their heads about was to figure out the first maneuver that would put us on that path to go around the moon and get home. And I was obviously not involved, but I assume there's some discussion about was that the right thing to do. Some people were arguing maybe a direct return, which would have used about all the propellant out of the service module. But at any rate, we got that maneuver done, and Jim Lovell asked me to look at consumables. We knew by then we had powered up the LEM. We had a good vehicle that normally, if fully powered up, and flying the mission would have lasted 2 days. So one thing was obviously we're going to have to do some stretching on power to get back. And I figured we could go to a power down of 18 amps. And I still have a card where I did this grocery store arithmetic and calculated that we could get back to the entry point, and then that was at 150-something hours. That we could make it on electric at 18 amps on this 30-volt system, but we ran out of water, which is water for cooling. I think about 5 hours before entry interface. But I'd had data in the system book from Apollo 11 where on that vehicle, when they left it in orbit, they turned off the water valve, and we watched the systems fail. And the first critical element failed at about 8 hours with no water cooling. So I figured we had some pad there, 3 hours at least. So anyway, we were in good shape. Now, it was interesting, sometime later, so I felt we'd get back to an entry point, but sometime later, years later, I went back in and reviewed some of the inner loops in Mission Control, and particularly in ECOM, which was the big action loop right after the calamity, and then later with the command module people. And it was interesting to hear the dialogue of them wrestling with the problems. We'll call it professional arguing through the troubleshooting initially for almost an hour, trying to save the second oxygen tank. We lost tank 2, and there was a slow leak had evolved in tank 1, and we never really knew quite why that was, but nevertheless, they went through troubleshooting, arguing to do what steps to take next to try to isolate the leak. And finally got to a point of where they run out of ideas. And it was obvious in their voices. I knew many of the people personally, some I recognized from the voices. They were just deflated. They were down because they knew they had lost the spacecraft. It was about that time that Glenn Lundy called them back to attention. He had replaced Gene Kranz, his team in Mission Control by that time, and told them we got to get the ship shut down because we're starting to eat into the entry batteries, the batteries we would need to get through entry, small 344 amp hour batteries. So it came right back to attention, and now there was a little bit of a discussion in a similar way of how to shut this thing down, because the command and service module was the mothership. It was never supposed to be shut down in flight, no plan to shut it down in flight, and there was no book to shut it down in flight, the checklist. So they had to ad-lib during that time now how to shut this thing down, and it would have been easy to just pull the main bus tie breakers and you'd have killed it quickly, but they worried about harming systems, and they wanted them to be back, so they were already in their minds saying, we want it to be back in good shape when we power it back up for entry. So they certainly didn't feel we had lost everything at that time. Anyway, we progressed on, and they were smarter than I was, people that looked at the requirements for power down, and actually worked us on board in the lunar module down to 12.5 amps on a 30-volt system. So that's about on your home, if you had a sofa and 2 lamps on either end with 3-way switch, that's about having those 2 lights up to the 3rd click. So that's the kind of power we had. And as a result, at that lower level, there was not enough thermal insulation on the LEM. It was never planned to operate down at 12.5 amps. I think our lowest was right around 32, 35 amps. And power descent to landing, you're up about 60 to 65 amps. So we were way, way below the specifications. The vehicle got very cold and damp. And in the lunar module, because of weight, there were no inner walls. It was netting material, which you could see through, and water was building up everywhere. At that temperature, now I'm guessing in the LEM down to the probably mid-30s Fahrenheit, a little above. The command module, it froze the water tanks. In fact, the water tanks in the command module were still found frozen after it was recovered and inspected on board the hangar deck and the ship on the aircraft carrier. So anyway, this water was built up. I could look in there and see around every corner of a plumbing or a wiring bundle, a glob of water sitting there, sort of shimmering from a little bit of vibration from glycol pumps or whatever. And that was worrisome. And one thing that really saved us even at that point was what had been done after the Apollo 1 fire. There had been a set of very rigid wiring specifications established when they reworked the ships. I saw it more from the Grumman angle. At that time, I was up at Grumman testing lunar modules, and one of the assignments I got was to join a crew to inspect LEM 1, the first unmanned LEM we flew, against this wiring criteria, which required wiring ties every so many inches on each bundle, and if you had any wiring clamps, they had to be perfectly round and not egg-shaped, carefully sealed at all connector interfaces with a material called Melcor. And when we inspected LEM 1, we wrote over 1,000 crabs with wiring problems. And LEM 2, when we looked at it, we decided it was well along, it just need to be rewired. So it just got pushed aside and was supposed to be the first manned vehicle, and it became the backup for the unmanned flight possibly, and LIM 3 became the one that first flew manned. So anyway, that wiring, those wiring standards really saved us, I think, from suffering a wiring short in our situation with all that water. Jack Schwager and I went into the command module while Jim maintained calm and attitude in the LIM, and we started the power up of the command module. Another challenge for people on the ground, because there was no power up procedure. They had to invent that, although they had a leisurely 3.5 days to do that. But at any rate, we got ready to do this power up, and that was a little over 2 hours from when we were going to re-enter. So the amazing thing was that checklist was perfect. Perfect in the sense that normally if you're powering up and you don't have everything up along the way, you end up with warning lights. Not that anything's wrong, but that's just normal for the configuration of the vehicle. And that normally would have stopped us to now figure out what's going on. But every warning light that came on was called out at exactly the right spot. So we were able to get through that procedure very, very rapidly. Jack, incidentally, when we got in the command module, we had to get a towel out and wipe off the instrument panel, because everything was covered with water to see the instruments. And of course, we worried about, or thinking about water behind there. When we first started the power up, the first steps were to push in all the circuit breakers that had been pulled out on 2 large circuit panels. And Jack suggested we push in only 6 at a time, and he called it when we'd start pushing in breakers. So we'd push in 6 down a row and stop briefly to see if we smelled wiring insulation burning, which would give you a nice odor. And we could quickly pull out those 6 and figure out which was maybe the culprit. But we went through that whole thing, and we did not have any problems. Just one last thing, the entry now, you have to realize we had frozen that vehicle for almost 4 days. Water tanks were frozen in it. We violated specifications on certainly all the avionics, the electronics. And it came back to life and gave us the second most accurate splashdown of the program. Only Apollo 10 did better, as best they could measure the splashdown point to the ship. And so that was another one of the, I call it the miracles of Apollo 13.
Thank you, Fred. Gerry.
Well, I spent 9.5 years in the control center during Apollo. I started as a GNC during Gemini, and then became a flight director right before Walt's flight. And let me sum it up before I get into some detail. It was so much fun. It was exciting, but it was a hoot. Every flight we had had a problem. Some were nagging, some were very serious, like 13 and 12. But it challenged us in mission control, I think, to be at our best. We had to be. And I've often thought about how were we able to do that? Well, for one thing, we had a bunch of young people. That was Gilruth and Kraft's point from the beginning. They wanted to go out and get some young guys, and there weren't any gals to speak of at that time that were taking engineering or even science. And they did. And they wanted that because they didn't want some of the old aeronautics people who were great and became some of our leaders. They didn't want to have that ingrained, this is the way we do this kind of thought. And Fred mentioned John Aaron, who made the call on Apollo 12, and he also made the call on 13 and most of the power stuff that we did. He was in his early 20s. from a little college in the state of Oklahoma, and he actually majored in physics. He didn't major in engineering. But we had a bunch of people like that. And then I think the secret of Apollo was our leadership. We had, and our leadership model was so important, we drove decisions down to the lowest possible point where the expertise was. We didn't try to elevate things and bring them up high because we were brighter the higher up the food chain you went. That was really brought home on Apollo 13. Let me tell you a quick story. I had been on duty and turned it over to Kranz. I went out to actually play a softball game, and they came out and got me and said, "You better come back to the control center." And so when I got in there, Gene was going through hoops trying to figure out what had happened, and Glenn Lunny had just arrived. I've always told Kranz I turned over a perfectly good spacecraft and you screwed it up. But immediately we started figuring out what we had to do, and Fred went through those early steps of getting back on a free return, and then try to do a direct return after that. And what we did, we came up with about 3 different options. One of them we call the PC+2, Paracynthian +2 maneuver, which would speed us up by a day getting home, and it would also, and we'd use the lunar module to do that. But it also put us back in a good landing spot, because I can't remember where we were headed on free return, but it was way out in the middle of nowhere. So Lunny and our 2 teams had worked most of these 3 options. And I never will forget when we were ready to call the PC+2, that's what Glenn and I liked, we went up into the viewing room with most of NASA's leadership there. There was Tom Paine, who was the NASA administrator. Gilruth was there. Debus was there. Rocco Petrone, the Apollo mission director from headquarters, was there. I think Von Braun was there, although I can't remember for sure. And of course we had Kraft and Deke Slayton and all the leadership here. We went through, Glenn and I briefed this crowd and said, okay, here's what we can do, and this is what we think we ought to do. We think we ought to do the PC+2. And at that point, we just left it right there. We just stopped. And there was silence. You know, I think quite often today you'd say, well, have you thought of this, or have you thought of that, or why don't you do this? There was total silence. Finally, Tom Paine, the administrator of NASA at the time, said, how can we help you? They trusted these 2 young kids to tell them what we were going to do, and that we had figured it out. They trusted us, we trusted them. And that was a great secret of Apollo, is the trust went up and down, and the decisions were made at the right level. We went back into the control center, said, okay, we got a plan. We did PC+2 and got them home. Mission control, I said, was fun. That leadership helped. But it was also a dynamic time. And I think there's a message here for people that are going to go back to the moon and on to Mars. Operating with humans, cislunar or deep space, is different than Earth orbit. Your recovery times, if you have a problem, you can't get home right away. So you've got, even the comm delay at the moon gave us problems early on, until even on 8, we were stepping on each other. And we finally, the Capcoms went to a old World War II aviation over, kind of like we were talking on simplex. But we were talking over the top of each other because there was about a 1.5 second delay, not all due to distance, but our networks were slower then. And so I think you need to think about the future, Mark's guys in the control center and the astronauts and everybody else, that operating in deep space is a whole lot different. Of course, when you go on to Mars, it's totally different, and with the comm delays and all. But I really think what the people today are just as good as we were. There's no doubt in my mind. I watched them when I was center director here. I've watched them since. They are really good. They just need the mission to get pinned down and say go. There's one other thing I wanted to say. Mission operations, if you include all of that, I think too often we overlook Kennedy Space Center and their launch ops. Their launch ops were flight ops in Building 30 here. And actually, during a countdown, we reported to the Launch Control Center. We were a go or a no-go. And those guys did an amazing job at the Cape. They really did get all those vehicles ready, and we could always count on them to do the right thing. At the other end, the recovery forces were also part of operations, and the DoD support was incredible. And so I think we need, when we think mission ops, think the whole thing. Flight ops, fine, Building 30 at JSC. But until Tower Clear, the Cape owns it, and after they're on the chutes, the recovery guys own it. So keep that all in mind, I think, for the future. And I wish, I hope you can stand on the shoulders of what we did in Apollo to get back to the moon, and Godspeed.
Thank you, Gerry. Yeah, that was awesome. You know, I consider myself a NASA space nerd, but every time I hear these guys, I learn something new, some great insights about their personal experiences. So now we are at the Q&A time, and we have a good amount of time left for question and answer. So like I said before, we'll start with a question or two that we got online, and then we'll open it up for folks in the audience. So if you are in the audience, get ready, start thinking about your questions. It's a great opportunity to talk to these guys. So Isidro, what's our first question?
First question, what are your thoughts on the increased reliance on computer simulations and analysis instead of building and testing hardware due to funding limitations?
Did you guys hear that?
Kinda.
So what's your thoughts on the current reliance on computer simulations as opposed to hardware testing driven by funding potential?
Well, I think looking back at the past there, nothing we did was more important and significant than running through the simulations before we got to go fly. Now everything in the world has gone to electronics, and you've got to be really good at electronics to even get it off of that. But it's not the same as being able to compare it. All of those things are saving some time. They're saving some money and some expenses. But they're approaching that in a way that leaves you less of a sense of confidence at the time you have to do the operation than before. I may be alone on that.
The only thing I can relate to is some of the things that were done in early shuttle. I'd left the astronaut office and 4 years worked for Aaron Cohen in the orbiter project office. And of course, we were fighting a number of problems, as you do with new vehicles, weight being one of them. But aside from that, we had budget problems and worrying about schedule. We were looking at ways to take money out of the program. For instance, Enterprise I flew, we canceled the second Enterprise. We had 2 of those. One got canceled. Testing, we curtailed in some degree. For instance, test, thermal back test, where we had tested whole vehicles in Apollo. On the shuttle, we tested 1 OMS pod and 1 payload bay door. Was sort of the thought, we'll make sure we got a lot of thermocouples on Columbia, and we can do our thermal testing on orbit. So that approach was taken. What vibroacoustic, and you have to realize this, the shuttle vehicle itself was not like the capsule perched way up on top of this big rocket, but it was sitting right where all those engines were running, solids and 3 liquids. And the acoustic levels were higher on shuttle than Apollo on the spacecraft. We did the aft section vibroacoustic. In fact, the building here, we did those tests, and they had to add horns in the vehicle, in the facility, to get to the dB level for those tests. But the crew cabin was deleted. Now that bothered me, and I argued that the other way, because I think you got to test what you consider are the most critical elements, and that was one I felt was that way, but that one we deleted also. Frankly, I wasn't worried about primary structure as much as secondary, which you don't have a finite solution on, and I could see it launch all the computers coming off the racks with the secondary structure, that kind of thing. But that was taken. We did no end testing to get redline data. I'd argued at one point to get another $7 million out of Mike Malkin to do. We had a number of engineering development articles to take them in some of the back 40 here test facilities we had at Johnson, to take those component level items and system level items to redline, to get redline data. And we really did not do that, which we hadn't done in Apollo. So again, any redline data on the shuttle was going to be garnered on orbit when it failed. You'd get your redline data. So things like that were curtailed with, you might say, some risk. Probably the biggest one was the OV-99, was a structural test article for shuttle. And it was to undergo not just structural tests, but also fatigue testing in the Lockheed facility at Palmdale, California. And Tom Mosier, he was head of, with instructors here, division, built a story that he had to take, as he said, he had to take to God to get approved. But we limited structural testing on OV-99 to 80% loads and completely deleted fatigue testing. Now, the latter wasn't too big a concern because we knew we weren't going to fly 24 flights a year by then, which was kind of the mission model. So that was done to save that hull and turn it into a flight vehicle. I think you have to look at how critical and do the right homework and studies to really decide, can you delete, can you really, and with confidence and conscience, delete testing on real hardware?
I think it's a combination, and I think, as Fred says, you need to look at those tests that are critical and that you really should do. For example, we tested the lunar module and the command and service module in the large thermal vacuum chamber here. We did the whole mission sequence, and we did the command and service module and the lunar module with the crew. So we did that whole mission, and we learned a lot. So you gain a lot from these tests, and you need to take a hard look at not deleting something just to save money when it's critical and important that you do it.
Great, thank you. Let's see, one more question online, and then we'll do in the audience. Go ahead, Drew.
Next question. What do you think the next step in timeline should be for human space exploration, and is the current plan viable?
So what do you think the next step in human exploration is going to be, and do you think this current plan is viable?
I definitely have an opinion about that as time is going on. And what that's related to is the people today are talking about landing on Mars. It was Elon Musk, you're going to take a bunch, 1,000 people there and let them set up life and things like that. I think a lot of the suggestions about what should be next comes from how successful the push has been in the past. People don't seem to be keeping up with the relative costs about it and what the difference in priorities now is. For example, Apollo 7, excuse me, not Apollo 7, Apollo, the entire Apollo program. That was a $20 billion program that got approved. And because we weren't 100% efficient, that program really cost $25 billion. $25 billion back then, today, is equivalent to about $150 billion. So when they talk about doing something out there, they need to understand that we have to be able to address those costs. Or, and this is one of the places where I've got a positive on some of the computer systems that are going on today, they can accomplish some of those things on computers, which is a lot cheaper. But they're talking, I think a lot of the drive today is behind somebody's emotional thoughts about it. And when they're talking about landing on Mars, some people say in 5 years, 10 years, whatever. Believe me, it's going to be some decades before we land on Mars. And when they talk about going to Mars today, they're talking about it based on how good our operations with spacecraft are today. I don't even hear them discuss all of the obstacles in being able to go do that. Secondly, since the Apollo program, they started exploring Mars, landing unmanned vehicles on there. And in my opinion, we now know so much more about Mars than we ever knew about the moon when we went to the moon. And so I think eventually egos will enter it, including my egos on some of these things, and they're going to go out and get men to land on Mars. But believe me, it's not where we're going to move humans when they're wiping out the Earth. It's going to be a place where you just continue to do some research out at the end, out at the edge of it, on doing that. So I guess there is a plus with doing this, computerizing these things compared with doing it. And we'll be going to the moon and doing some work, but I think it'll be a long time before we set up human-operated facilities on Mars.
Just one thought to add to that. I think sustainability is probably the key word. We've got a plan now, NASA and international cooperation, commercial input, a lot of that. I think we need to learn how to move around in deep space. One day we're going to need to for some reason. And I think anything we can do to get that sustainability, like the Gateway, possibly at the moon, would be one step in that direction. But we've got to get it a little more routine so that it's not so much an event as it is a capability, an infrastructure. And so to me, what we're doing now is trying to take a step, and we're short of money, there's no doubt about that, trying to take a step at building that infrastructure so that we can get in and out of space all the time and be able to go deeper and be able to stay there for a while. I don't care where it is, somewhere. And I've got a little different philosophy point on it. I think one day we may, and it's maybe 5,000 years from now, but we may have to get off this planet. Not because of global warming or anything like that. We just may use it up. And I think we need to learn how to move around out there so that we have some options. And I think the course we're on, well, I wish we had more money and could do it a little faster and a little better cadence. It's just not happening right now. But you guys are struggling through it pretty well. And so I think there is a need to go deep, and we got to learn how to do that.
Well, I think the next logical step is going back to the moon, and you can learn an awful lot about living and working in space beyond Earth orbit on the moon. And if you have a problem, you're only 3 days away from the Earth, and you can learn and really understand how you can operate on Mars, learn that on the moon. And we need to develop systems that have long lives, because you'll need systems that are dependable and reliable, that can operate for long periods of time if you go to Mars. So the moon is really the next logical step, and that's a good training ground for the going beyond that. But also it's very interesting scientifically. So there's a real benefit to going back to the moon, and that's really the next logical step.
Good, thank you. All right, questions from the audience? I can outlast you. Yes. Could you just come up through that little gap there and head over to the mic, if you don't mind? There's a mic right there to your left. Yes, ma'am.
Thank you so much for your wonderful story, and I really love Apollo's story because it was even before my birth. And yeah, as I understand, actually many of the people outside of our group, they believe all astronauts would be the uniform because we go through the very similar selection process, but now we look around is how diverse a group we are, and it's really amazing. And Apollo crew also, until I read the books, I just thought like most of the Apollo crew might be the uniform because they are all same ethnicity and an all male kind of thing. But after meeting some of them, I realized it's a really diverse group. But what if you had a kind of more gender diverse crew you had during your Apollo mission, and then maybe in the future we will have a more diverse, not only by the gender, but also ethnicity, and what might be different, and then what if you had a female crew during your flight a long time ago, and what would be the concern or positive part, both of negative or positive part, you can kind of expect in the future for the crew composition?
So maybe if I could re-summarize your question.
Sorry.
No, it's good. Thank you. Thank you for asking it. So if you, now we see that our astronaut corps is much more diverse, right, than it was in the 60s. So if you had a diverse crew in your missions, what would be some of the concerns and constraints, and what do you think are some of the benefits and concerns for the future with a more diverse crew?
Personally, for the crews back in the 1960s and the 70s, I would not be pushing for a more diverse crew. Getting things tested was a real challenge. And I look at it as the history of our country and the history of our planet. It was maybe the greatest challenge and accomplishment, like we went through, that we've seen. And so back in those days, I wouldn't be doing it. People have a hard time looking at it. We look at Apollo. And the room we had, because it looked okay, because we float around zero gravity, we didn't have this much room. Three of us, no way. Well, you and I, we could sit in kind of like that. So what I'm getting at, it takes people who are motivated. It takes people who are willing to stick their neck out a little at least. And I happen to believe that one of the big advantages of those days was the fact that everybody had to be a military fighter pilot, test pilot. Most of them were test pilots. And I think that was a big plus. that helped the success of those programs. I may be alone in that, but that's how I feel.
Yeah. Well, I think just the considerations of what could happen dictated a couple of things in the Apollo situation. First of all, 2 people were going to land on the moon and 1 person in orbit. There was a possibility, obviously, that 2 people on the moon weren't going to be able to get off. So the command module person was going to have to be fully capable to operate that machine all on his own and come home. Similar situation for the lunar module. We did EVAs outside, rough terrain, sharp rocks. There's a possibility you may lose 1 person on the lunar surface due to a suit failure. So either person of the lunar module had to be fully capable to fly that vehicle back up through a rendezvous and mate with the command module and come home. Now, I don't know, in 16G, you might have been able to drag the person up the ladder, I don't know, but bring them home too, you'd hope. But basically, you had 2 situations where 1 person was going to have fully the skill and capability and background experience to do that kind of a role. So that's what kind of dictated, I think at the time, with the exception of Jack Schmidt, we were all military pilots. We'd all been trained in high-performance aircraft. We had years of experience, a lot of hours. So I kind of think that's kind of what dictated and how we ended up with those roles during that time. Now, if you had more crew members, you need to diversify. We were talking earlier, I was talking about a mission to Mars. One guy you're going to have, or a lady on board, is one who can fix anything. That's going to be a special skill. I would not be a good person for that. I hit my hand when I tried to nail a nail, but you need a good skill that way. So you do need the diverse skills. But it again depends on the mission, the type of mission, and how many people are aboard.
Excuse me, one more thought. With the things that we've accomplished up there, we are now able to send people along who would not be appropriate for the test missions on that. You don't have to be a military fighter pilot, test pilot, or any of that these days. A lot of people that get selected are not. I happen to believe that that's only a luxury that we have today.
Yeah, I'd just like to say, so for today, we're blessed in that, thanks to the military, for jobs that we think would require fighter pilots, we have some incredibly skilled people, including Ann McLean, who is not only a pilot, but also fought in combat. So we're incredibly lucky. So for those skills that need that, now we have it. And I think it's going to add considerably to our ability to execute the missions in the future. So now if we, sorry, Mr. Abbey, did you want to comment? Yeah.
I think also you need to consider that back in those days, there are a lot of people that didn't think humans could even operate in space. And there are a lot of people that were wanting to fly more animal flights because they didn't think crews could really work and operate in space. So that really makes the point, I think, that Walt and Fred have emphasized, that you're looking for people that could really perform in that kind of a stressful environment.
Okay, good. Let's take another one from the audience.
Hi, this is a question about collaboration. And Walt touched briefly on living with a contractor, and Gerry also brought up the KSC launch ops as well as the DoD recovery team. Pulling on those or other examples, could you discuss how extensive collaboration between centers or external entities enabled these successful Apollo missions? And in your view, how important is collaboration in these deep relationships going forward?
You guys hear that?
In Apollo, we had a very close relationship to the contractors. As a matter of fact, probably by today's rules, we may have violated some, because we thought together and we came up with common solutions between the two. We had people in the control center early on, for instance, that they looked just like us, but they were contractors. we had some military guys in the control center. They looked just like us. So I think we actually early on had very good collaboration, and what we didn't have was any international partners to deal with. But I think we got the most, it was a plus, the relationship. I know these guys, I know Fred lived in Bethpage almost where they built the lunar module, and that's why he knew it so well. By the way, during Apollo 13, we probably had as many as 50 or 100 guys watching consumables and plotting them and all. He was doing the same thing. And when, I don't know if you remember this, when the flight was all over, his stuff matched ours. And he was doing it by himself with a pencil. And, but I really do think the relationship with the contractors and all of the people, the other centers, was great. And there were some ego issues here and now, kind of like different teams in the NFL. But by and large, the cooperation, the collaboration was really, really good. And it was one of our secrets.
Okay. We got time for one more. Let's do one more in the audience.
Mr. Haise, you touched on the fact that the backup crew training, the backup crew assignments that you had contributed to the success of swapping out last minute in the Apollo 13 crew. And my question was, could you or Mr. Cunningham talk a little bit more about what the most critical pieces or elements of training as a backup crew member were in order to enable that?
Did you guys hear it?
No.
Basically, so it was about backup crews. You both mentioned about being a backup crew. So the question was, what do you, I'll try to summarize it, sorry. But what would be the most important part of training as a backup crew to be as effective as necessary to fly the missions?
I think if you're a backup crew in those days, I can't talk about the timing today and how long they go through this stuff. In those days, the backup crew had better been willing to pay the price on whatever it was in case, so he could be replacing prime crew if necessary. And for example, on Apollo, what the hell's my friend's name that got in the last minute? What's his name?
Oh, Kim Annerly?
No, it wasn't.
Schweiger's place.
Yes, Schweiger, yeah. And here's a guy that had been doing a lot of other things too. But he came up essentially perfect when they just run the test through to do it. So the backup crew needs to be able to do whatever that job is, the primary crew, in my opinion.
Just to add to it, basically we had a training plan and a published schedule of activity every day. And for instance, prime and backup would normally swap afternoon or morning in the simulators. So one would take it in the morning, one in the afternoon. Virtually it was a mirror image. We attended all meetings together. We'd split sims with integrated sims with mission control. So virtually a backup crew did, and I felt as a backup, if you looked at the training records, I probably got a little more hours in the simulator than the guy I was training to replace, because the prime crew got drawn off with other things, media, press conferences. Yeah, they missed training days. I never missed a training day. So I think the backup, like I said, was fully capable of jumping in, which was essential. We did not want to miss a launch. Because of not having a crew. You didn't want to wait till the moon came around another month to get back in the right position. So we trained as if you could replace the whole crew the week of launch.
The same thing actually applies on prime crews when you got a limited number of people on it. The prime crew has to be able to replace, to save that crew, whatever is necessary. And rightly or wrongly, by the time we flew on Apollo 7, I literally felt I could replace either one of my the other two friends on it to do that job. And so maybe a lot of that's just having the right mental attitude, but it's what I strongly recommend.
All right, great. So that, again, I want to thank the Association of Space Explorers for hosting this Apollo panel here at JSC, and special thanks to our distinguished panelists for sharing their great experiences with us. So would you join me in thanking them again? All right, thank you. So this concludes our program. I do want a couple of announcements. So if you are an ASE member or partner, would you stay in your seats while we allow everyone else to leave the auditorium and the foyer, and then in a few minutes we'll all head to lunch. Thank you.